Hello everyone, my name is Pedro and I'm doing the multi-scene circuit in the computer.
Hello everyone, my name is Gaston Bargan. I will build the circuit on the bench and then I will do the new school method.
Hello everyone, I am Suzanne Stone and I will be showing how to old school measure on an oscilloscope.
Okay, so now let me introduce you to the multi-scene part. First, let's gonna set the power source. It's gonna be an AC power source. And we're gonna set it to 5 VRMS and 250 Hz. And we're gonna change the title. It's gonna be a V in. And let's put the resistors. I'm gonna put a 330 ohms right here and a 1.6. Okay.
How many times do I have to do that?
Let's put this guy otherwise. Okay, and now let's put the ground.
So which one of these do I move?
And the oscilloscope. Right here. We're gonna set the channel A to measure the power source. So it's gonna be in this position. And channel B to measure this resistor. Okay, so let's set the voltmeters to measure the power source and the R2 resistor. I'm gonna put the voltmeter here and set it to AC. Erase the values. Put the positive sign here and the negative sign here. And the other voltmeter. And we're gonna do the same. Set it to AC and erase the values. We're gonna run the circuit. And we got 5 volts for the power source. And it's the same for F, VR, and S. It's the same value. Okay, and for the R2 resistor, we got 0.855. That's gonna be the VRMS2. First, we're gonna measure the value of the power source. That's gonna be the channel A. So first, we want to hide the channel B, and we're going to bring this one to Y max, and the line number 1 to Y min. Okay, this value over here is the voltage peak to peak. Now we want to measure the period. First, we bring the line number 2 to where the line ends. You see this value over here, this is the period of time that the sine wave begins and ends. Okay, so now we want to measure the period of a resistor 2. Yeah, line 1 is already in the beginning. We're going to set line 2 to the part where it ends. Yeah. Now, the time value you see here, this is the period, this is the time it takes the sine wave to where from where it begins to where it ends. Now we want to measure the voltage peak to peak. First we set this line to Y max and the line 1 to Y min. Okay, this value you see here, this is the voltage peak to peak.
Let's have some fun building the circuit on the bench. First of all, we need 3 black wires, 2 red wires, a resistor, a 1.6 kilo ohm resistor, and a 330 ohms resistor. Then we need to plug all the black wires in the negative line, and all the red wires in the positive line. Both resistors have to be in series, so the first one gonna be here and here, and the other one is gonna be in the same line, the vertical line here and here. Right now I'm going to measure all the stuff using the new school method. First of all, we need a function generator cable, a black probe and a red probe, and an oscilloscope cable. Okay? Now I'm going to turn on the function generator and the multimeter, the digital multimeter. Now I'm going to plug all, going to put all the positive cables together like this, and all the negative together, just like this. Okay. Then I'm going to move the frequency wheel until I get my 250 hertz, my frequency actually. 250, 250, almost there. Here we go, 250 hertz. And then I'm going to change this, the digital multimeter, to an AC circuit. So I will use the amplitude wheel to change the voltage right here, until I get my 5 VRMS. First, I'm going to change the range, and I need to get 5 voltage RMS here. Almost there, I got it. Continuing with the new school method, I have to turn on the oscilloscope, and with all the positive and negative cables together, I'm going to turn off the channel 2. I'm using the channel 1. I'm going to press auto, and I have my wave right here. So I'm going to voltage, scroll down until I get V peak to peak, then peak to peak voltage, then V voltage RMS, then voltage period, and then time frequency. As you can see, my voltage VRMS is 5.14 voltage. My period is 4 milliseconds, and my frequency is 250. This is the across the voltage source.
The next thing that we'll be looking at on our oscilloscope is measuring our voltage source minus the 2 resistors. What we'll be looking at again is our voltage peak to peak. Now we can see that our voltage peak to peak is different now. We are at 1, 2, 3, 4, 5, 6, and apart here almost half, as well as down here. So we're going to call that 7 divisions, and we're going to multiply that by our 2 volts. So we have 14 volts peak to peak. 14 volts peak to peak. So to get our voltage peak, we'll divide that by 2. That would be 7 volts peak to peak multiplied by our 0.707, which gives us, looking at our calculator here, we're going to go ahead and say 7 volts times 0.707, and our VRMS is 4.949, so practically 4.95. And you'll see if we looked up at our multisim, we would see that our diagram shows us that our VRMS is at 5. So it was very, very close. Now we will be measuring the time. The time is taken in divisions going horizontally. So you'll see to make one cycle, we have 1, 2, 3, 4 divisions. 4 divisions times the amount of time that it took to complete one cycle, which is 1 millisecond. So back on our calculator, we will take our 1 millisecond, 1 times 10 to the negative 3, and we will multiply that by our 4 divisions. That would be our time when we do 1 divided by that answer. So you will see that the hertz, the frequency, is 250. So 250 hertz for this example.
Right now, I'm going to measure the voltage RMS, the voltage peak to peak, the frequency, and the period across the resistor 2. First, I need to plug all the red cables in there. Put it together with the the black cables with the black wires, just like this. The positive with the positive, the red with the red, and the red with the red. And the oscilloscope positive, I have to plug it in with this resistor 2, with the positive. Once I have built all my circuit across the R2 resistor, I'm going to the oscilloscope and click on measure and use voltage V peak to peak, voltage VRMS, and time the frequency. As you can see, the peak to peak is 2.4042 volts, the VRMS is 830 millivolts, and the frequency is 250. Voltage time period, my period is gonna be 4 milliseconds.
We are going to be discussing how to calculate using the old school method on our oscilloscope. So we are going to be discussing how to calculate using the old school method. Now, if you can see the squares or the divisions that are on the oscilloscope, what we're looking at first is the length of time that it takes to make one cycle. As you can see, we have our squares counting 1, 2, 3, 4 squares from the start of the cycle to the end of the cycle. So our first calculation, and of course all of these calculations are being done across R2 resistor. So our voltage, our frequency is going to be our 4 divisions times our seconds that the amount of time that it takes to make one cycle. So it's the divisions per cycle and the amount of time that it takes to make one cycle. So for this experiment, we're using 4 divisions times 1 millisecond, and you're going to find your answer and then 1 divided by that answer. So what that would look like, right here, we would take our 4, let's go ahead and start with our milliseconds first. So we'll take our 1 times 10 to the negative 3, that is our 1 millisecond. We will multiply that by our 4 divisions, and then we will take the 1 divided by that answer. And we get 250 hertz. So for this example across R2, we have 250 hertz. The next thing that we'll be looking at is our voltage peak to peak. To find voltage peak to peak, you're going to start at your 0, counting up to your highest peak, which would be in divisions 1, 2, and a half. And then starting at 0 and counting down to your lowest peak would be 1, 2, and a half. So we have approximately 5 divisions in our example here. So we have 5 divisions, and we are going to be multiplying that by our 500 millivolts. As you can see, 500 millivolts. So we'll be using our calculator for that, using our 500 millivolts, which is, again, times 10 to the negative 3. 500 millivolts. We will be multiplying that by the quantity of divisions, which we have as 5 divisions, as an answer of 2.5. So that is 2.5 volts peak to peak. Now, to get our VRMS, we're going to divide that by 2 to get our voltage peak. So divided by 2, that gives us our voltage peak, and we'll be multiplying that times 0.707. So our VRMS across R2 is 0.883. Now, if you look up here at the example on our simulator, you will see that it's very close to what our simulator gave as the answer as well, which is 0.855. So you can see that the voltage RMS is the same on both the old school and the new school and the oscilloscope.